The muscular system has several functions, primarily producing movement. To produce movement requires muscles be attached to the bones. This is the reason we discuss the projections and depressions on all the bones. So to produce movement requires, in essence, that all of the bones within the appendicular skeleton and even some places within the axial skeleton are classes of levers. Now remember from your freshman science class, when we talk about levers, you're talking about the location of the fulcrum versus your load and your effort. So we have three classes, first, second, and third class. The difference between the classes has to do with how much increase in force we get. So first class levers and second class levers, you generally see an increase in force. With third class levers, we usually see a change in the distance, so we get more distance. An example, when you look at where the bicep, what the bicep can do compared to the gastrocnemius, on the calf, we lift a heck of a lot more with our calf muscle than we do with our bicep. Because if you're a 250-pound guy, you're easily lifting that with your calf. You can't do that with your bicep, and that's one of the main differences with the classes of levers. The other thing, though, you can lift that weight, but you can't move it very much. This distance is limited. Whereas the bicep, remember, I can take my arm from perfectly straight all the way up almost a full 180 degrees. So the advantage of a third class lever is the distance that we move. So just keep that in mind. Also remember that our fulcrum here, that's always our joint. So the fulcrum is the joint. So where that fulcrum is located compared to the attachment points of the muscles determines the class of lever. Now, what this means is we have to attach at 2 points. So we went through this with the string lab. If I'm attached at 2 points, one is movable and one is immovable. So our origin is immovable, our insertion is movable. That means, generally speaking, we have an area of the muscle that stays stationary, and then the other part of the arm, the movable portion, moves towards it. So you're always bringing your insertion towards the origin. And as we discussed and found out, there always has to be a joint in between. And this is why we did the lab, because you learn all of the actions best by actually acting them out. Now, the other thing that we talked about is that all of our actions work in opposition. So remember, our movements, flexion and extension, are opposites. Abduction and adduction are opposites. Dorsiflexion and plantar flexion are opposites. So we see everything working in concert. However, the main thing to remember is that, if I have a muscle that does, a completely different set of muscle undoes. So if one muscle shortens, the other, one muscle does flexion, another muscle has to do extension. The same muscle can't do both movements because muscles only pull. They never push at anything. This also means that movement is more than just the primary action. So we have different jobs for the muscles. We have what's known as the prime mover. So when I flex at my elbow, the prime mover is obviously the bicep. Okay? If I'm talking about flexion, that means the antagonist is going to undo. So if my prime mover is flexing, my antagonist will do extension. Synergists then have a different role. Synergists basically add to the movement. So when we talk about a synergist, for example, if you look at plantar flexion, we're looking at something like the soleus is a synergist with the gastrocnemius for plantar flexion. Fixators are what help immobilize an area. So for example, when we throw, you'll notice that you have different parts of your different joints in action at different times, and so certain things have to be very stable. If I'm doing flexion with a real heavy barbell in my hand, my shoulder actually needs to stay very still while I do that movement, and those would be the fixators, what helps to compensate the joint. Now this is going to lead to the other function, one of the other functions within the muscular system, which is stabilizing joints. But that's the role of the fixators. Now, the nomenclature is actually really important. One of the things you have to remember about nomenclature, it's descriptive. You're being told a lot of information by a muscle name. So here's a new one, rectus. Rectus means straight. So if I have a muscle called the rectus femoris, you know a couple of things. You know the organization of the muscle. It's perfectly straight. We also know by femoris that it's going to be in a particular location. You see the same thing with transversus and obliques. So you have abdominal obliques. Well, those are your love handles. You also have transversus abdominis. Again, you know the region, you know the organization of the muscle fibers. Now, the significance of the muscle fiber direction is that helps to explain the different movements or the way I can produce movement, because going back, all muscles shorten. So the direction that I move determines my origin, insertion, and the type of movement produced. You also see it in terms of size of muscle. We have gluteus maximus, gluteus minimus, gluteus medius. Okay, you see it with longus. You can have a longus versus a brevis. Brevis means short. Location, temporalis, the frontalis, the occipitalis. Again, the femoris. You get the idea. You see it in other ways with the number of origins, tricep versus bicep. I have the biceps femoris versus the biceps brachii. The brachii tells you arm, femoris tells you leg. So we have two different areas that have biceps. But again, the main point there is two heads. The location, sterno, digitorum, femoris, dorsi. Those are all basic locations. Now, notice we can also do it in terms of the origin and the insertion. The sternocleidomastoid, cleido clavicle, sterno sternum, mastoid, the mastoid process on the skull. So that means you have a muscle that attaches right at the joint between the sternum and the clavicle, attaches to both bones, and then comes up to the mastoid process. Well, when you shorten that muscle, it brings the mastoid process towards the sternum and the clavicle, and that's why you can turn your head and you can feel that muscle contract. The shape, deltoid, trapezius, we talked about those. The action, flexor, extensor, so you could have a flexor carpi ulnaris. Okay, that tells you the action, it tells you where it's attached. So the main thing, again, everything in a muscle, it's descriptive. It's telling you something. It's telling you a story about that muscle. So back to the basic functions. As mentioned, we see stabilization of joints. We also see adjustments or maintaining posture. Your ability to hold yourself in a particular position when you bend over, when you sit straight, all of that is related to the function of the muscles. Facial expression is actually very important, and controlling openings and protection. Some of our muscles, that's what they do. So the whole existence of our abdominal wall here is protection. It's to help to maintain the viscera and keep the viscera in a single location. To protect various openings. We don't want everything to have access to all the openings in our body. And one of the most important in terms of our physiology is generating heat. Our ability to maintain a constant body temperature. That ability to just be able to control the temperature that we have. We talked everything about the role of the skin in terms of shivering and sweat. Well, the shivering, that's what our muscles do. And so the typical normal body temperature that we maintain, our core temperature, all comes from what's known as an asynchronous contraction of our muscles. But those are the basic functions of the muscles.